Today we are going to determine the value of Boltzmann constant by studying current volt characteristic of a forward bias diode. The software we are going to use is Multisim. The theoretical value of Boltzmann constant is K is equal to 1.38 into 10 to the power minus 23 joule per Kelvin. Boltzmann constant gives the relationship between the temperature T of the particle and the equivalent thermal energy E is equal to KT, or simply saying, at room temperature T is equal to 300 Kelvin and the energy at that temperature is 0.02586 electron volt. For determining the value of Boltzmann constant using IV characteristic of a forward bias PN junction diode, we need to study the forward current of an PN junction as well as reverse current of an PN junction. So the characteristics of a PN junction in reverse bias as well as forward bias is shown as in the figure. The diode current equation is given as I is equal to Is exponential QV upon my NKT minus 1, where N is equal to 1 for germanium diode and N is equal to 2 for silicon diode. After after deriving the equation, we get to the point where K is equal to Q 2.303 nt into 1 upon my slope, where the decreasing slope is the one we need to calculate. Working formula for this equation, working formula is this, and the circuit diagram we need to draw for Multisim is going to be this. Before going to the result, I am going to show how the circuit is drawn in Multisim. So here I have simulated the whole circuit as given in the presentation. Here this is a potentiometer we are going to use so that we can vary the current through this part. This is the voltmeter, although I have used multimeter for this. This is a voltmeter, and this is for measuring the current across the diode. So this is ammeter. We are going to use a potential source of 5 volt here and a ground potential. So as we run the circuit here, you can see that at 0%, or this is not allow any current to flow through this part, so the voltage is nearly 0 as well as current is 0. And now as we increase the percentage, the current starts flowing as well as the potential increase. By measuring the current as well as voltage for different percentage of value, we can plot out the graphs in Excel. This is the circuit we need for silicon diode. For germanium diode, we need to just replace this diode with nothing. So here I have concluded the results of the silicon diode. This is a circuit diagram as I have shown in previously. The voltage, current and the log I characteristics, we need to record this from the Multisim circuit. Here is the voltage value as well as here the current value, and we need to apply it for every single percentage. There are actually many values you can use for getting a graph like this. This is the forward bias characteristics of silicon diode. So for determining the K value of Boltzmann constant, we are going to plot the graph between log of I versus V. So taking the previous value of log I and the voltage, we get a declining graph like this, where we can take the slope of each point and we can determine the value of Boltzmann constant. Similarly, applying this experiment for germanium diode by replacing the diode here and applying the same concept, we get a graph. The slope will vary according to the different type of diodes used, but the formula for each is different, so we will get the same value, almost same value for this if we compare. So we successfully determined the value of Boltzmann constant using the current voltage characteristic of a forward bias diode. So nearly it is equal to 1.38 into 10 to the power minus 23 joule per Kelvin.